Hello, welcome back to the channel, and today we're going to continue our discussion on functions, but now we'll go over quadratic functions and what those are, how we can graph them at a very basic level, okay? So first, remembering what functions are when we have a certain expression equal, input variable and an output variable, and remember, we're representing a relationship between these two variables through the numbers of this function. We have an introduction to functions if you want to check that out. It's going to be linked right here, okay? So first, for us to understand how a quadratic looks in a graph, let's just plug in some points with this example of quadratic, okay? So let's say we take the points when x equals -4, when x equals, let's just choose a few, -1, and when x equals 3. Okay? And let's see how that looks. Okay, so when x equals -4, we plug that in here, we have -4 squared plus -4 minus 6, which here is 16 minus 6 minus 4 is 6, if I'm not mistaken. Yes? Oh no, this is actually, sorry. This is 8. Let me just write it out. 8 minus 4 minus 6, which is 8 minus 10, which is -2. So we know that when x equals 4, y equals -2. We can graph our points. X equals -4, y equals 2. This is one of our points in our function. Next point, x equals -1. Plug it in, squared. This, again, we already went over how this works in the last video. 1 minus 6 gives us -6. Which is all the way down here. Look, we almost don't have one. When x equals -1, y equals -6. Last point, when x equals 3, we have 3 squared plus 3 minus 6, which gives us 9 plus 3 minus 6, which is 6. Our last point is 3, 6. Oh wow, that is too high. Here, 6. Okay? So here, first we can see something a bit weird, right? It's different from the functions in our last video. They don't, as x increases, we don't see y also increasing. Here, from here to here, x went from -4 to -1, and the y went a lot of stuff down. But then, when we went 4 to the right again, it went up. So this represents what we see in quadratic relationships, which is that we find kind of a curve when we connect all of these points. A curve instead of a straight line. This is the first essential element of a quadratic function, which is that it's graphed in a parabola. If you were to find all of these points, they would follow some kind of curve like this that we call parabola. And this is the first important thing of how to graph them. Now, the second important element is where it crosses the x-axis. These are what we call the intercepts of this function. And they're extremely important when solving, when trying to graph a quadratic function, but also when, in some certain problems, it will be useful to find which x value, sorry, didn't label the axis, very important, which x value will give you y equals 0, which x value will make your output 0. This will be used in a lot of situations. For example, if your y is profits and you want to say which y will make you have 0 profits, or you have 0 loss or profits, and if your x is over time, maybe you'll say, oh, at this certain point in time, you will have, well, we can get into a more specific problem in some other video, okay? But the thing is that when we're solving for these variables, well, let's put down what this would mean in numbers. If you wanted to find the point where y equals 0, you can just create your, write down your function, but instead of plugging in anything for x, you're plugging in something for y. In this case, you're plugging in 0. Because, well, again, you're wanting to know what y is, what this quadratic is when y equals 0, okay? And for you to find these x values that give you y equals 0, you actually do something that we've learned before, which is solving a quadratic equation. And we have a video just about that, but here you see this is exactly the formats that you used. The way it looks, it's exactly the same as the way you solve a quadratic equation. That you set the quadratic expression equal to 0, and if you don't remember, what you do is you want to find, again, the x values that will make this side 0, so you can make this equation true. And the way you do that is that by factoring this expression. And we also have a video specifically in that. I'm not going to get into a lot of detail, but in this case, you can do sums and products. Sum to 1 and multiplied to -6 is 3, gives you 3 and -2, which gives you x plus 3 and x minus 2. And this would be your factored expression equals to 0. And now if you want to find, again, your x-intercepts, you want to find which x values will make this side equal to 0. And for that, you will have two options, right? If this piece of the expression is equal to 0, it will make this whole side 0, which will make it equal to the other side and make the equation true. So we need to find what makes x plus 3 0. X plus c equals 0, solve like a normal equation. X equals -3. Second one is this one. If x minus 2 is 0, we'll make this whole side 0, making the equation true again. So when x minus 2 equals 0, we want to find which x will make this equal 0, which is x equals 2. So now we know that these are the two solutions. Why? Because these are the two values that would make this side equal to 0, that would make your output 0. You see, we set this equal to 0, so we would find which x values make the output 0. And what does this mean? So let's graph these points now. When x equals -3, y equals 0. If we graph this, we get -3, 0. And I see I wrote the intercept wrong before because I didn't find it mathematically. That's why you need to find it mathematically so that you don't just draw something incorrectly, okay? In this case, the line would cross through this point, something like this. Your second would be x equals 2. So when x equals 2, y equals 0. If we go to draw that point, x equals 2. Y equals 0 is your other intercept. Again, and you can use that to graph your point, but also very useful in some word problems where you want to find which x value makes your y 0, makes your output 0. Okay? And that is it. That is why you use a quadratic equation equal to 0 in dealing with a quadratic function. Because these are very different things. Make it clear this is a function, y equals something, and this is an equation. We set this side equal to 0, we set y to 0 to find which x's give you an output of 0 so that you can find the times that it crosses the y-axis, the x-axis. Because the x-axis is simply when y is 0. Everything in this line just means that your y distance is 0, okay? We have another video about specifically how to graph using different things like finding the vertex, axis of symmetry, because there are other elements to graphing your quadratic function, okay? And we'll have a video on completing this square as well soon, so make sure to check that out. Thank you very much. See you.